Hey guys, welcome my fellow Chemilites. Today I'm going to be teaching us how to solve for molecular formula. Okay, now it's very easy, though it might look a little bit too much, but it's very easy. We have to take it step by step. Okay, now first of all, we have to pick out our details before we start solving, and we have to look for the empirical formula first before we look for the molecular formula. Okay, let's read together. An organic compound with a vapor density 56.5. Okay, now when you hear 56.5, what formula relates vapor density to finding your molar mass? Let's move on. Has the following percentage composition of carbon 53.1%, nitrogen 12.4%, oxygen 28.3%, and hydrogen 6.2%. Now, they say the molecular formula of the compound is, and now give us the relative atomic masses of each of the elements. Okay, now before we start, first of all, there is a formula for looking for molecular. There is a formula to look for the molecular formula. So now it goes like this. Looking for the molecular formula, you write it molecular formula. It's equal to empirical formula. This empirical formula is affected by M equal to what? Relative molecular mass. But now we're not giving relative molecular mass. What were we? Okay, guys, how do we look for the relative molecular mass? Which formula we go? We're giving vapor density. So now what do? There's a formula that says vapor density is equal to relative molecular mass divided by 2. Okay, now since we have a formula like this, how do we now look for relative molecular mass? We cross multiply, which means relative molecular mass will now be equal to vapor density times 2. So now we're giving vapor density. So relative molecular mass will be equal to 56.5 times 2 to give us what? It will give us 113. 113. Okay, now since we have gotten the relative molecular mass, what next do? We have to what? We have to find our empirical formula. Okay, now since we have to find our empirical formula, now let's go. We bring out what? We bring out the elements. We have carbon, we have nitrogen, we have oxygen, and we have hydrogen. Now let's bring down their percentage as usual. Now the percentage is 0.1 over what? Nitrogen is what? 12.4. We have oxygen to be what? 28.3, and hydrogen to be 6.2. Okay, now since we've written down the percentage, what do? We divide by the atomic mass. We have been given the atomic masses, so let's just include them down. Carbon is what? 12. Nitrogen 14, oxygen 16, and hydrogen is 1. Alright, so now since we've brought them down, we'll divide through. Let's divide through. 1 divided by this will give us 6.2. 16 divided by 28, what will it give to us? Let me punch your calculator. 28.3 divided by 16. K is going to give us 1.7. Let me write 1.77. Alright. Punch your calculator to confirm. Okay, now nitrogen, let's divide through. Nitrogen will be 12.4 divided by 14. We're going to get 0.88886. Alright. So now, if we divide this, what will we get? We get 53.1 divided by 12. We will have 4.425. Alright, since we have gotten this. What next is the next procedure to do? We pick the smallest. And which of them is the smallest? We have this to be the smallest. So now let's divide through by 0.886, 0.886, 0.886, 0.886. Alright, now let's divide through. Okay, dividing through, what do we have? Then punch your calculator. We have 4.425 divided by 0.886. Okay, we have approximately 5. So write it down, 5. Now, this side you have 1. Now, here, what do we have? 1.77 divided by 0.886. We are going to have approximately 2. Now, our hydrogen, what do we have there? 6.2 divided by 0.886. We have approximately 7. Now, since we've gotten our empirical formula, therefore this compound can be written as this. The empirical formula of the compound will be written as this. We have C5, nitrogen, O2, and hydrogen 7. Okay, now what next do we do? We have to look for what? Our molecular formula. This is why we're here, to look for the molecular formula. Okay, now I'm going to wipe out this whole everything here so that we can be able to see. Okay, since we have cleaned it, now this is now time for us to impute our formula. So now our molecular formula, let's impute our empirical formula that we've gotten. We've gotten our empirical formula to be what? C5, H7, O2, and N. Alright. Equals to what? We've gotten our RMM to be what? 113. Alright. For us to be able to get N, because N is the next thing we have to solve for before we are able to get our molecular formula. And N will now be what? We will now have to calculate everything here to give us what? So now let's calculate together. We have C to be what? 12 times 5 plus 1 times 7 plus what? Oxygen is what? 16 times 2 plus what? Nitrogen 14 will give us equals to what? So now punch your calculator. If you punch your calculator, what will you have? You are going to have 113. So now, since we've calculated the whole empirical formula, the mass of the whole empirical formula to be 113. Now let's get N. If 113 bracket N is equals to 113, therefore N will be what? Divide both sides by the coefficient of N. Cancel out, cancel out, cancel. We'll find out that N is equals to what? N is equals to 1. Alright, so now if N is equals to 1, how do we look for a molecular formula? So now, therefore, our molecular formula will be what? Molecular formula will be equals to what? To be equals to C5, H7, O2. So if one multiply everything here, it will still give you the same thing. So therefore, we actually our molecular formula is same as the empirical formula. Okay, that's how to solve it. And so if you see this kind of thing in another question, just apply the same formula, you are going to get your answer. Definitely. Okay guys, another question. Now if we see this, what do? We have to apply the same method. Though this one is a little bit more it's not complex though, but it's like trickish. So now let's solve this. So now after seeing this, we're given our vapor density. First of all, if we are given empirical formula, which means we're not solving for empirical formula again, we've gotten that already, and we're given vapor density. What next do we have to get? Now let's write down our formula. Molecular formula is equals to what? empirical formula affected by our n equal to what relative molecular mass. But we were not giving relative molecular, we're only giving vapor density. And we know we have a formula that says relative molecular mass is equals to vapor density times 2. So now our relative molecular mass is what? Vapor density is 42. So 42 times 2 will give us 84. Give us 84. Now after getting our relative molecular mass, what we do? We have to input it in this formula. So now let's write, looking for n. Now we are going to write an empirical formula out. Our empirical formula says CH2 bracket n equals to what? Our relative molecular mass. Now n will now be what? Now we have to find the value for this. So carbon is only one carbon and hydrogen 2. So carbon is 12 plus 1 plus 1 times 2 is going to give us what? 14. So therefore 14n is equals to 84. Divide both sides by 14. Cancel out, cancel out. N is equals to what? We have n to be alright. Since we've gotten n to be 6, now let's get our relative molecular molecular formula. Now getting our molecular formula, we have molecular formula to be what? Is equals to what? Our empirical formula CH2 bracket what? We have our n to be 6. So now since we've gotten our n, last time we got only 1, which we times it. 1 times anything is the same thing, but now we have 6. So now our molecular formula will be what? 6 times 1 carbon will give us 6 carbon. 6 times 2 hydrogen will give us what? 12 hydrogen. Okay, so this is our molecular formula. And now you've seen that solving molecular formula is very, very easy and cheap. It is a cheap question. Anytime you see this question in your exam, you should be very, very happy. Okay, guys, question 3. Now, when we see a question like this is the sweetest because almost everything has been solved for us. So now what do? We use our normal formula, we have molecular formula to be what? Molecular formula is equal to empirical formula bracket n equal to what? Our RMN, that is relative molecular mass. Okay, that's fine and good. Now we have our empirical formula, we have our relative molecular mass. Let's look for n. So now our empirical formula CH2O is equals to what? 120. Now we have to calculate what is inside here to look for n. So we have what? Carbon. Carbon is 12, hydrogen is 1, and oxygen is what? 16. So now let's calculate. We have this to be what? Is equals to what? 12 plus 1 times 2 plus what? 16. What will it give to us? 16. So now this 12 plus 4, 12 plus 2 will give us 14 plus 16 to give us 30. Now our answer is 30. So 30n is equals to 120. Alright, so now divide both sides by 30. What do we have? 30 cancel 30. Alright, 3 go here 1. 3 go here will give us 4. Alright. Since we've gotten our n, we have n to be what? We have n to be 4. Now, next up is to get our empirical formula. Now, let's impute what we've gotten now. Okay, our empirical formula therefore is equals to what? Let's write the compound. bracket what? N. But we've gotten the value of N to be what? 4. So now let's impute our answer. 4 times carbon will give us 4 carbon. 4 times 2 hydrogen will give us 8 hydrogen. And oxygen will now be 4 oxygen. Alright, this is our molecular formula.
You go get the way hunger go do you and see your body go just to tell you sleep, 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 sleep. No sleep, oh, you then die, they go. I swear.